Welcome to the Pro Tips video series designed to arm biology learners with background knowledge needed to succeed during upcoming lessons. I'm Professor Workman, and today's Pro Tips are about designing good experiments. The basic logic of all experiments is the same. It's two streams converging over a waterfall. There is a concept you are testing to see if it affects an outcome. But in order to do that, you attempt to control all other noise, keeping the environmental conditions of the experiment steady. Here's another way of looking at it. With inputs on the left, arrows marking the passing of time during the experiment, and the outcome of the experiment resulting at the end on the right. So the thing you're testing and the environmental noise all lead to an outcome. Now let's consider an example. Lots of people are lactose intolerant. When we consume dairy products, we suffer distressing symptoms. So, as an experiment, I have tried taking one Lactaid pill to test whether it prevents my symptoms. But in order to convince myself that one pill works, I controlled the amount of dairy I paired with it. It wouldn't be a fair test if I took one pill and drank 3 cups of milk. That's too much. So instead, I have drunk a controlled dose, just 1 cup of milk per one pill, and that works pretty good for me. I've tried that many times and it consistently works. But what happens if that cup of milk is in a chowder, a soup that I eat hot, or perhaps in the form of ice cream that is consumed frozen? Might the temperature of the dairy food impact the effectiveness of the Lactaid pill? Unfortunately, I can tell you from personal experience that it does, particularly with cold ice cream. I may not know exactly why, but I know that one pill is enough for 1 cup of milk, but not enough for 1 cup of ice cream. So, for a fair experiment, I should control temperature when I'm testing whether or not Lactaid works to prevent my symptoms. In experiments, you should try to control all aspects of the environment that could conceivably impact the outcome. This reduces noise, so you can better assess if the thing you're testing has the predicted effect. Now for some science jargon. The streams that combine into the outcome are called the independent variable, which is the special thing you're testing on purpose, and the controls, which are all those aspects of the environment you keep constant. Then the outcome is the result that depends on those inputs. So that's called the dependent variable. Now, do you think I tried Lactaid just once and was perfectly convinced that it would work for me? No way. I'm skeptical of people trying to sell me things. So I tried one Lactaid pill each time I consumed 1 cup of milk for several months before I trusted it. My repeated testing is part of the scientific process. It builds trust in the predictability of the outcome. Science doesn't rely on a single test. Instead, each experiment is run many times. Each test run might be called a trial. These trials replicate the original experiment, testing what happens when I take Lactaid versus when I do not. Each time a trial returns identical results, you gain confidence in the conclusion. This replication of the original experiment is required to convincingly document the relationship between the thing you're testing, called the independent variable, and the outcome, that's the dependent variable. In this experiment, the independent variable is whether or not I took a Lactaid pill. And the outcome, or the dependent variable, is whether or not I then experienced symptoms related to my lactose intolerance. After all these trials, I am pretty convinced that taking Lactaid matters, and I'm willing to spend money on them in order to enjoy dairy products. In summary, you learned that experiments are replicated in order to build trust in your conclusions. You also learned some new terminology. The concept you're testing is called the independent variable, while the environmental conditions you keep constant during all your repeated trials are called controls. And the outcome is the dependent variable. This is what changes when you adjust your independent variable. Thanks for watching. If you liked this video, you might consider watching other videos in the series. Here's my contact information, and I always welcome any feedback. mworkman@pima.edu. Good luck in your biology journey.